This lecture is about how industrial welding training will unlock Africa's human potential and end poverty within 10 years. But first, I will illustrate the current problem, then tell you how my path led me to be here with you today. I will close this lecture with a detailed program and organization structure we have created to solve this vexing problem and transform African nations into flowering centers of industry and prosperity. The work we do together will not only transform Africa, it will also support the well being of every inhabitant of the planet by unlocking the human potential talent in Africa that has not yet been enrolled in the global economy. I do believe that when this program takes flight, the seeds will be in place to eliminate poverty on the African continent within 10 years. Let's now look at how I have come to this conclusion. Primary commodities account for more than 70% of Africa's exports. Commodities leave the continent to other parts of the world where useful things are made from the commodities, then are imported back as manufactured goods. African leaders are widely recognizing the missed opportunities to expand home country manufacturing and are gradually taking steps to change this situation. African leaders are coming to recognize the problems around the lack of skilled artisans, welders in particular. As noted on this first slide here, the writer describes how Nigeria could become the new China through manufacturing. But over 50% of all manufactured goods required some level of welding. As noted in these other headlines, there is a severe lack of skilled welders in Nigeria and across Africa, not to mention the shortage of 355,000 welders in the United States. The Dangote refinery has a permanent shop with 50 welders, and 48 of those welders are from India. Only 2 are from Nigeria. This not to mention the over 1,000 welders that were needed for the construction. So this is a serious problem affecting all parts of Africa. Here is the problem, and I have a direct message to the CEOs of major energy, mining, and power companies with expansion plans across Africa. In November 2023, while visiting Uganda with the CEO of a contractor working on the East Africa crude oil pipeline, he learned that half of his welders had left for paying work in Nigeria, working on the Dangote oil refinery project. Some of you CEOs may think that you can resolve this welder shortage by training some local welders to work on your projects, but I have worked with this trade for over 40 years. They keep their boots strung tight and their suitcases packed. When a better opportunity comes up, they do not hesitate to leave for higher pay and greener pastures. Let this example be a warning to all companies planning projects in Africa. The traditional approach to trying to solve your local content labor will not work. With $800 billion in planned projects in upstream energy alone, this is a serious problem. Over a year after my visit to Uganda, Total Energies is still scrambling to staff its East Africa crude oil pipeline with skilled welders. As reported in January 17, 2025, the ECOP project signed an MOU with Kayamboygo University to implement national content initiatives. Sadly for Total Energy shareholders, this is 3 years too late, in my opinion. These and other energy and mining companies investing in African projects are sleepwalking into a nightmarish hell if they do not act immediately to invest in effective training of African welders. I have personally been involved as an expert witness on about $100 billion in global mega projects with budgets larger than $1 billion, the largest being a $35 billion LNG project. And I know from research done on 300 such large projects around the world that 65% of these projects did not meet their investment objectives. For example, the cost of the 650,000 barrel per day Dangote refinery project grew from $9 billion to $20 billion, and the schedule grew by about 300% from its original schedule. The imported labor with the necessary skills were at least 50% more expensive than the local people could have been, according to a study performed by one of the Nigerian associates of African Skills and Development Group, a sister company to GFP International. When I worked on projects for Rio Tinto Mining Company, I was told that the average cost overrun was well over 50%. When I look at the register of risks to African investments, the 2 greatest risks at the top are political risks and the lack of skilled labor. Both of these risks are mitigated when the project owners earn political goodwill by investing in local capacity building, and welding is the most critical of these skills. Before I talk about the strategies and solutions to these problems, let me share my personal story. I have always had an unquenchable curiosity about how the world works, and my parents knew me to be a dreamer. As a boy, I had a National Geographic poster on the constellations on the wall next to my bed. Every night, I would look at that map and visualize myself traveling amongst the constellations and visiting other planets. Try it as I may, I could not visualize an eternal and infinite universe. If the universe was finite, what would be outside of it but more space? Today, I rest these questions on the words of scriptures which say, "By the word of the Lord the heavens were made, and by the breath of his mouth he made all the start. He gathered the waters of the sea together into a heap. He made the ocean stay in its place. He commanded, and it stood fast." The human mind may never be able to comprehend the vast and infinite universe, but I am forever grateful to even have the tremendous gift of being alive and to have the gift of human consciousness to contemplate these questions. Since that time in my youth, I have spent more time thinking about the earth and what a remarkable place it is. Originally formed 4.5 billion years ago, human civilization as we know it is only 6,000 years old. If you compare that with the number of seconds in a day, civilization would be about 1/10 of 1 second old. I have always had a curious mind exploring how things worked. History and anthropology have never been of great interest to me, however, until recently when I became old enough to see many changes during my own life. For example, during my 71 years on this planet, the Earth's population has grown from 2.6 billion to 8 billion people. I have always been interested in how things worked, which has led me to greater interest in technology, science, engineering, and more recently, economics and history. Let me share with you a few things I have learned and how this has brought me here today. In 1969, at the age of 16, I spent a summer living and working in Venezuela, South America, on a small ranch that was cut from the Amazon rainforest. I lived in a one-room mud hut with a Venezuelan boy named Jose Jesus. Of course, the hut had no electricity, no running water, no sanitation, and we slept on hammocks. That is me on the left, cooking a meal over a fire made of wood gathered from the rainforest. Our daily routine consisted of gathering firewood from the rainforest, starting a fire to cook on, and our diet consisted of black beans, rice, and cornmeal. Every day after breakfast, we went to the edge of the farm and cleared the land, chopping down trees with an axe and cutting the underbrush with machetes. Throughout the day, we could hear the mating call of the howler monkeys echoing through the thick rainforest. We had a small pen where we kept a wild boar that was being saved for eating, and kept a lookout for other boars we might be able to hunt with a rifle we had. While living in that mud hut in the Amazon jungle, the United States landed a man on the moon on July 20th, 1969. People living in that rainforest were gathering together to listen to radios and celebrating the event. I heard Neil Armstrong when he famously said, "That's one small step for man, one giant leap for mankind." This event changed the way we all perceived the universe and changed the way I viewed my own place in the world. When you realize that this was just 336 years after Galileo was imprisoned as a heretic for suggesting that the world was not flat, it gives perspective on the pace of change that is occurring all around us. One day, while living in that rainforest, a boy named Raul came to our place asking for some food. "Miguel," he said, "can you feed me? I have not eaten in over 3 days." With my privileged background growing up in the United States, I had never met anyone who had not eaten in 3 days, and this experience had a profound impact on me. When I returned home to my family, I considered becoming a Marino missionary to work with the world's poor, until I met a girl I liked. Instead, I studied extra hard in high school and went on to Michigan Technological University to get an engineering degree, then started a fruitful career in engineering, construction, and project development. 5 months after my return from Venezuela, Gunnar Myrdal wrote a book titled The Challenge of World Poverty. The world population was approaching 4 billion people, and there was a food crisis across the globe at that time. Then came the Green Revolution. Human creativity began to address the hunger crisis using ingenuity and the natural gifts that our Creator gave us to use on this planet: fertilizer, irrigation, better crop management. Referred to as the Green Revolution, these innovations helped the world's population grow from 3.6 billion to 8 billion today. My curiosity led me to an exciting career working on underground mines, schools, high-rise offices and hotels, bridges, power plants, a sports arena, an LNG plant, and many other projects in the power, mining, industrial, and commercial sectors. I still enjoy a career as a construction management consultant, but I never forgot that hungry jungle neighbor boy who had not eaten for 3 days. About 20 years ago, I developed a heart muscle disease and ended up in a hospital emergency ward for 3 days, not sure if I would survive. But with modern medicine and a cardiac pacemaker, I now live a healthy and normal life, thanks to Dr. Katsianis and his surgical team at Abbott Hospital in Minneapolis and the genius engineers at Medtronic, the pacemaker manufacturer. Grateful for the life extension, the old calling to do something with my life came back to me, and I formed a group called Global Faith Partners, now called GFP International. I pulled together a group of people from multiple faiths in the Minneapolis, Minnesota area to see what we might do together to address some of the problems with world poverty and hunger. A Catholic priest from Africa invited me to come to his village and see how life was for the people there. I traveled 1,500 kilometers across East Africa with 3 Catholic priests over dirt roads while visiting remote villages that had no phone service, no electricity, no plumbing, or clean water. The HIV/AIDS crisis was in full force, and 1 in 10 villagers were orphaned children. There were orphans everywhere. I held many of them in my arms, and I fell in love with Generation Z, the generation that is now the young African workforce in great numbers. I was very surprised to find the same conditions I had experienced 36 years earlier. We have put a man on the moon, encircled the globe with satellites, invented the internet, cell phones, laptop computers, and made many other great leaps in science and technology, but here in many parts of East Africa, things have not changed for these children and millions of others. Some friends and I, through GFP International, helped these families. During my trip to Africa 20 years ago, I also found women everywhere still spending hours every day gathering firewood for cooking like I did in Venezuela in 1969. Experts conclude that about 600,000 Africans die every year from inhalation of cooking smoke. Mostly women suffer this fate. Thank you for listening to my personal introduction. Now let me get into the real subject of this lecture, beginning with the historic role of various tools and metals in human development. In 1981, Buckminster Fuller wrote a book called Critical Path, another book that caught my attention back then. Bucky Fuller, as he was known, examined ways to optimize and conserve the use of resources for the betterment of mankind. He developed this timeline chart which shows the dates when the Earth's elements were scientifically discovered. Among Buckminster Fuller's many inventions was the geodesic dome. Based on his lifetime of research and invention, he once said that through the creative use of materials, all of humanity could live in an abundant life free from hunger and want. I am inspired by the work of Buckminster Fuller to conclude that poverty in Africa will be largely eliminated in 10 years when industrial welding, fabrication, and manufacturing skills are widely taught and put to work. This chart is a map of all the Earth's elements that our Creator gave us to work with. It includes the metals I'm going to talk with you about: copper, iron, and bronze. The photo on the left is from a recent tour of the Museum of Natural History in Washington, D.C. Before metals, humans used stones that were chipped into shapes to perform various functions. The Stone Age lasted from 2.6 million years ago to 3,500 BC. Copper was an important metal used by native people in prehistoric times, as shown in the photo on the right. Archaeologists and treasure hunters have found prehistoric tools made of natural copper, such as harpoon tips, arrowheads, and spears. In the Americas, Native Americans were the first to mine and work the copper of Lake Superior and the Keweenaw Peninsula of northern Michigan between 5000 BC and 1200 BC. I acquired the specimen of native copper on the left in 1975 when I graduated from Michigan Tech, which is in the copper country of northern Michigan. Copper tools with this metallurgy have been found 8,000 kilometers away in South America, which indicates the importance of the natural copper metal. The Bronze Age was the heyday of the chariot. It was one of the main technological advances that allowed for the Indo-European migration throughout Eurasia, and the chariot remained a key status symbol and weapon of war of Egyptians, Mesopotamians, Hittites, and Mycenaeans until the Bronze Age collapsed in about 1200 BC. 1200 BC is identified as the beginning of the Iron Age, and we are still in the Iron Age. And the photo on the right shows some of the agricultural uses of steel in farming tools made from iron in early America. The map on the left shows the diffusion and spreading of metallurgical skills, mostly during the Copper and Bronze Age of Eurasia. Again, chariot was the key tool of the Bronze Age. Today, industrial welding skills are necessary to support a wide range of industries and job creators such as oil and gas development, power generation, mining, manufacturing, farming, steel structures, shipbuilding, and others. Work in these industries have a job multiplier effect. For example, work on utilities, which requires advanced welding skills, have a multiplier effect of 14.8 other jobs created for every job in the utility business. These other jobs include things as restaurant workers, service industries, suppliers, and related trades that result from new job creations in the base economy, while every job in manufacturing creates another 9 related jobs, and so forth, as shown in this graph. In contrast, retail trade only has a job multiplier effect of 3.2. Now I'd like to talk about the uses of metals and welding, beginning with the mining and manufacturing, then agriculture, energy, shipbuilding, and other industries. Let me explain how mining, metals, and manufacturing evolved in the United States to illustrate an example of the industrialization process. North America was blessed, as I said, with a large deposit of native copper in the upper part of Michigan, near Lake Superior. The production of native copper from mines in this area once provided 45% of all copper mined in the United States. Copper, of course, is an essential metal in electrification. The Quincy mine was by far one of the largest of these mines in northern Michigan, where many immigrants from northern Europe worked when they came to the United States. Natural native copper was chipped out from the rocks and sent to the surface for separation in stamping mills. Not far from the copper region, the Lake Superior Iron Range still produces 75% of all iron ore in the United States. Note the large mining equipment that is used to operate these mine sites in northern Minnesota. Of course, this equipment requires industrial welding and machinists to manufacture and to maintain this equipment in good working order. In contrast to the mechanized mining used in modern mines, the cobalt mines in the DRC Congo still use crude hand mining methods, as shown on the left. Those are human bodies you see in the background. Again, the manufacturing, operation, and maintenance of mechanized mining equipment requires skilled industrial welders. Every modern mine shop has welders and machinists and workshops where they maintain and repair the equipment when necessary. The iron ore that is mined in northern Minnesota is shipped across the Great Lakes by large ore boats from the port of Duluth, Minnesota, to the steel mills in Pennsylvania and other areas around the Great Lakes, such as Gary, Indiana. The United States is blessed with 2 long coastlines, a chain of Great Lakes that are navigable by ocean-going ships, and the Mississippi River system that also carries freight and large cargo barges. As a young boy, I toured a French ship that was docked in Duluth, Minnesota, to pick up grain that was grown in the middle of the U.S., known as the breadbasket region. As a boy, I was surprised to see ocean-going ships thousands of miles inland like this. The Great Lakes, coastal shorelines and ports, and other navigable waterways of the United States are one of the reasons we have such a robust economy. Here's one of the ore boats entering the port of Duluth for picking up a shipment of iron ore to take to the mills in Pittsburgh and other steel mill towns. With its proximity to the Great Lakes shipping and major manufacturing centers, Pittsburgh, Pennsylvania became one of the centers of steel manufacturing in the United States. Those of you who follow American football have likely heard of the Pittsburgh Steelers football team. After smelting and manufacturing the steel in Pittsburgh, it was used in auto plants in a nearby Detroit, Michigan, where Henry Ford developed the assembly line concept to build a very successful business, the Ford Motor Company, that still exists today. Prior to Henry Ford's innovation, cars were mostly made one at a time. The welding schools of excellence we envision will include training in robotic welding to prepare students for modern manufacturing and other applications. We see that governments in East Africa are taking important steps towards industrializing their economies for the benefit of their people. Two examples are in Kenya, where the leaders have embarked on an industrial park strategy, and in Tanzania, similar efforts are underway with the Bagamoyo Port Project and other industrial developments. A critical question is, what skills are needed to make these strategies successful? Another key industry where welding and metalworking is essential is modern agriculture. 65% of uncultivated land on Earth is in Africa. Yet, hand-hoe agriculture is slowing agriculture transformation in Africa, according to studies. While there may be some local concern about the loss of farming job if mechanization is used, we will show how this transformation occurred in the U.S. with little or no impact on the lives of farmers in the farming sector. Every town in rural America had a blacksmith shop like the one you see here. These early blacksmith shops were involved in making horseshoes, horse-drawn plows, and buggies. When I was 10 years old, my father took me to a blacksmith shop owned by Jimmy the blacksmith. His shop was a mechanical wonder. All his equipment included a drill press, table saw, bandsaw, and grinder were all driven by one single electric motor, connected to each piece of equipment with an elaborate system of overhead pulleys, shivs, and drive belts. Jimmy would start up the motor, and all the belts and shivs would start to spin and rotate. Each piece of equipment had a drive clutch between it and the rotating belts and shivs. When he wanted to engage a specific tool, Jimmy simply engaged the clutch. Jimmy was a skilled welder and an indispensable hand in helping farmers maintain their mechanized farm equipment that was used on the family farms surrounding the village. Without his welding equipment and skills, the farm equipment could not be maintained or repaired when needed. Many people are fearful of change, such as might be in the case of farming in Africa. Will small farmers be put out of work and lose their means of income if things are mechanized? This fear cannot be dismissed, but I believe that there is nothing to fear here. Changes take time and should be plenty of opportunities to make the transition. For example, in the year 1900, the average farm size in the U.S. was 59 hectares of land. 124 years later, the average farm size is 187. What I have seen in my own lifetime is that when farmers finish with their work in older age, many of their children leave the farming life and find other means of income in industry, trade, technology, or business. The smaller farms are consolidated with larger ones, where a single farmer can operate a larger plot by using mechanized equipment. This kind of a transition increases the overall efficiency of food production with an overall benefit to society. Again, welding is a critical skill in the manufacture and maintenance of farm equipment. Without industrial welding, this transition could not occur. In addition to manufacturing and agriculture, sufficient energy is a critical component in a modern industrial economy. Every type of energy development requires industrial welding skills, and energy projects are being planned all across Africa. Oil and gas energy is being produced and explored across the African continent, as shown in this diagram. According to Wood Mackenzie, industry plans to expand Africa's upstream oil and gas production with $800 billion invested in the next 10 years. This will require tens of thousands of industrial welders. The offshore gas fields require extensive production platforms at the gas field. In countries which have ample industrial welders, the LNG plants are built on site from the various pieces of pipe, valves, and fittings. In many instances, separate sections or modules of the LNG plants are fabricated in foreign countries, then transported to site and placed together, as shown on the lower right. With Africa's booming working-age population, I believe that it could become a key source of skilled welders to build its own energy infrastructure, in addition to become a source of LNG module construction to provide to the world market if government leaders and industry executives make the right moves and invest in training. Electricity generated from natural gas is cleaner than coal or oil. In 2022, natural gas accounted for 23% of the world's electricity generation, while coal accounted for 35%. These gas power generating stations shown on the left are all connected to the U.S. gas distribution system, which all requires welding to build. With the coming boom in natural gas production in Africa, this can happen across Africa as well, providing the energy needed to power a modern economy. I am not aware of a time in human history where the well-being of so many people is on the doorstep of such great potential leaps. In the U.S., 61% of homes use natural gas for heating and/or cooking, which is supplied through national and regional gas pipeline systems, which connect the gas fields to the homes. Construction of these gas distribution systems all require certified industrial welders. Africa will need these pipelines to benefit from the coming energy boom. According to the American Wind Energy Association, a single 5-megawatt turbine uses a total of 900 metric tons of steel. Industrial welding is a key skill in the development of sustainable wind energy. Projects in Tanzania, like the Julius Nyerere hydropower project, also needed industrial welding, in addition to the transmission towers that distribute power nationwide. In addition to manufacturing and agriculture, shipbuilding is an industry that is ripe for expansion in Africa. The global ship fleets are always aging. Cargo ships have a lifespan of 25 to 30 years. Oil tankers are replaced more often. As of 2022, the average age of all ships in the world merchant fleet was just over 20 years, meaning replacement is going to continue. China and South Korea compete for the largest shipbuilding industries worldwide, yet the size of their workforces is collapsing, as shown in the demographic profiles. While other countries and regions in the world are facing shrinking workforces, demographers predict that by 2050, a full 40% of the global working age population will be African. In our informal inquiry, we found that the cost of local African welders is about one-third to one-fourth of South Korean labor costs. Working with our sister company, African Skills and Development, we want to support the expansion of the shipbuilding industry in Africa by attracting investors and creating a consortium of companies working together. Dry docks will need to be constructed, and the welding skills need to be taught. I predict that in 10 years, Africa will be taking a large chunk of the international shipbuilding industry, if not sooner. Under my leadership, GFP International conducted a gap analysis to evaluate how East African welding schools could close the gap between teaching ornamental welding and industrial welding. This is not a criticism of the existing welding schools, because most if not all of the schools we visited were designed and operated to teach only ornamental welding. By those standards, the schools generally met the needs of an ornamental welding program. But the welding theory being taught in East African schools was generally good, but the major gap we found was in the skills development area. There are understandable reasons for this, as I will explain. I have personally visited and inspected these welding schools across East Africa over the last 3 years, often with the assistance of representatives of the American Welding Society and other welding training experts on our GFP International advisory team and consultants. Now let's look at some facts we found when inspecting a cross-section of East African welding schools in Tanzania, Kenya, Uganda, and Rwanda. We found that 85% of a student's time in East Africa was spent on learning welding theory and technology, and only 15% of time on skills practice. In contrast, current programs, which lead to welder certification skills, spend 85% of the time on skill practice and only 15% of time on theory. In general, Welding schools in East Africa had one or two welding machines for each 10 students. In schools that produce certifiable welders, there is a welding booth for each student, and each booth typically has one or two welding machines, including different processes. This means that a certified welding school requires 5 to 10 times the number of welding machines to produce the same number of graduates, but with certification. This will normally require larger and better equipped training facilities. We found in our study that the 23 welding schools we visited had between one or two welding machines per 10 students, as noted earlier, while modern welding schools have one to two welding machines per student, as shown on the right. Modern welding schools also have fully equipped fabrication shops where welders learned how to apply their skills in the industrial welding workplace, in particular fabrication skills. On average, the East African schools we visited only had about 25% of the fabrication equipment that fully equipped industrial welding schools have. The welding school at the left lacks welding booths, adequate lighting, proper ventilation, and sufficient shop equipment, and not enough welding machines to train industrial welders effectively. The school on the right is a school which produces certified welders in the U.S., with welding booths, ventilation, good lighting, and all the equipment needed. These basic welding training positions are identified by numbers and letters. The number represents the position, and the letter identifies the weld type. There are many variations to the basic welding curriculum, which are often designed to meet specific needs in the industries served by the school. The following slide lists the number of hours welding practice is required to pass certification skill tests for shield and metal arc welding, also referred to as stick welding. Stick welding is typically the welding introduction course. Later, other types of welding is trained, such as TIG and MIG welding. Let's take a closer look at the problem that exists across sub-Saharan Africa welding schools. As you can see in this tabulation, the total number of actual welding skill practice hours is 404 hours for a 12-week course at a quality South African welding school that prepares students to pass internationally recognized certification tests. This means that the student spends 84% of his or her time during that 12 weeks in actual welding, and very little time on welding theory. In contrast, this is a summary of the skill practice hours provided at a government-run welding school in East Africa. It includes a total of only 150 hours of skill practice training in stick welding over one entire years of school, and a total of 246 hours of skill practice hours over a full 3 years welding training program. This 3-year program only provides students with 246 total hours of skill practice versus 404 hours for a 12-week stick welding course that actually prepares students for certification. Sadly, this program prepares students to work on burglar bars, steel furniture, doors and windows, and other such ornamental welding crafts, but it does not prepare the students to enter the international structural and industrial workforce. This diagram helps illustrate the stark difference in training approaches. In the structural welding training course shown at the top of the slide, the student gets a 404 hours of stick welding practice in a 12-week course shown in the blue in the structural program at the top left of the slide. The student is prepared to take skill tests and earn IIW or AWS certificates for the positions it was trained to. The 3-year ornamental welding course shown at the bottom of the slide exposes the student to 3 welding processes, but only gives the student 246 hours of skill practice over an entire 3-year program. These students are not prepared to pass any internationally recognized skill tests and certifications. As a construction executive, these are the kinds of skill certificates that I require from a welder before being allowed to work on any of my sites, and this is a standard practice across the industrial world based on my experience and observation. Certificates that meet the requirements of the American Welding Society or International Institute of Welding are the most common certificates that I've seen through my career. Without a doubt, the government welding school curriculum that I showed above does not prepare students to obtain these certificates. However, I have talked with many African welders who mistakenly believe that if only they could have access to a testing center, they would be able to obtain these certificates and get good jobs. Sadly, this is flat wrong. Rigidity in the government education ministries' curricula must change, and they must allow the flexibility in the welding curricula applied at their schools. Unless and until this change occurs, governments are not only failing their students, but they are failing their industrial development efforts and industries who need welders with the certified skills that will meet global industry quality standards. As mentioned, we have anecdotal reports from the East African crude oil pipeline project that only about 2% of welders who applied for the project could meet the skill standards. We also note in recent reports in the Kenyan media that a major Mideast employer found that fewer than 5% of the Kenyans applying for skilled jobs met the requirements. Here is a certificate that merely states that the student completed a 480-hour stick welding course. This, too, does not appear to meet global industrial standards. It doesn't indicate how many hours of practice it was indicated, and it merely states that the student attended a 480-hour course. Student testing and certification by a recognized body such as the AWS, IIW, or Canadian Welding Bureau is what industries require. There are exceptions to this rule, such as local cottage industries in the African market, but if a student wants something equivalent to a global passport, recognized certification is the best way forward. I have shortened this discussion about certifications for the sake of simplicity, but there are other standards which govern welding work, such as the ISO 3834.2 standard and Section 9 of the ASME code, depending on the governing project specifications. My point is that training which focuses on skill development prepares the student for the world of work much better than the ornamental training described above. The skill practice curriculum examples I just showed you were from the South African Institute of Welding, where we sent 4 trainers to get trained in stick welding over a 12-week concentrated course. The cost of material used in this course, including welding rods, steel plate, pipe, and other consumables, approached $2,500 per student. This chart shows the number of people working in the various trades in the United States and the pathway to skill development, including electricians, carpenters, plumbers, welders, roofers, painters, and brick masons. It does not count all of those working in manufacturing trades, however. As noted, most trades can be learned with a combination of on-the-job apprenticeship supported with time spent on schooling that is specific to that trade. Except for welding, a worker can start earning money from his or her first day on the job as an apprentice, but welding requires the development of a basic skill level working under the eye of a caring and competent instructor before ever going to work as an apprentice. This fact, along with the cost of the materials required to train an industrial welder, means that the financial support is important to receive the industrial and economic benefits that can be realized from skilled welders working in manufacturing, construction, and general industry. Many trade school administrators ask me to identify specific projects or manufacturing plant jobs that will need welders, but I think there is a better approach to address this question. Another way to approach the problem is to ask how many welders are needed to run a modern industrial economy, and then look forward to develop a plan that is appropriate for the local country circumstances. For example, the United States has 409,000 people welding as welders according to the Department of Labor Statistics. This is approximately 1,200 welders per million of population. As seen in the breakdown in this chart, jobs are found in manufacturing, professional, construction, transportation, automotive, and other sectors. If you apply this metric to countries in East Africa, the numbers are quite surprising. With a total of 367 million people in the East African countries plus Mozambique, to reach a level on par with the United States, you would need 440,000 trained industrial welders. I am not suggesting that any of these countries develop a strategy to develop 1,200 welders per million population in the short term, but rather than trying to identify specific projects that will need welders to justify a welding program, each country should take a high view and integrate this thinking into its overall industrialization plans. Questions to be asked. How soon does the country want to reach middle income status? What are the electrification goals? What are the energy goals? What kind of energy mix will make sense based on proximity to fuel supplies and other natural resources? What are the goals to move manufacturing back into the home country from foreign suppliers? What kind of transitions are desired for agriculture? Designing a strategy for welding development is one of those chicken and egg questions. What comes first, skilled welder or industrialization and home country manufacturing? With slumping population growth occurring in most of Asia, Europe, and the Americas, against a backdrop of large demographic growth in Africa, this points to an accelerating demand for the industrial skills needed for economic development coming from Africa. Do African countries simply want to train a workforce to fill the needs in other countries in some kind of a brain drain or skill drain, or do they want to upgrade their domestic skills for use domestically to build up their local economies? What combination of both of these makes sense? I think that these questions are important to address at the policymaking levels and personal decision making by the students. I have always developed close working relationships with the men and women working on my projects, like this crew in Hawaii building a geothermal power plant. I came to know them all personally. They came from all parts of the United States, including Puerto Rico, Texas, Louisiana, Florida, the Navajo Nation, Utah, the Intermountain West, and many other places. My job as their leader was to support their success by making sure they had what they needed to be successful. All the information, materials, tools, equipment, and moral support they needed to be successful in their jobs. Sometimes a little discipline was required, but mostly positive motivation. With the cost of welding training relative to the East African economies, trade schools and students most certainly need financial support to be successful, either with outside grants or student loans. We have talked about some of the tools of the Stone Age, Copper Age, and Bronze Age. The key tool in the Iron Age today is the modern industrial welding machine. If I were the president of an African country, I would start out by buying a couple thousand multi-process welding machines and placing them in the vocational schools, train the top tier of industrial welding instructors, and modernize the training facilities as needed. If I were the CEO of a major industrial company planning projects in Africa, I would reach out to other CEOs and work together to boost welding training in a similar and significant way. We at GFP International are prepared to support this initiative with the modernization of 30 welding schools of excellence across Africa, so every student who wants training in structural and industrial welding can have access. I am personally inspired by the work of my great-grandfather, Henry Velez. Henry was a young French engineer who moved to the United States in 1891 and became the superintendent of the Utah Lehigh Sugar Company plant, where the new industry of sugar beet processing was advanced in the United States. He developed and patented many processes for making sugar from beets that could be grown in northern climates, including the reverse osmosis rotary disc filter. This new industry of making sugar from beets displaced many sugar plantations where slave labor often worked across the world. This sugar factory in Utah, where Henry worked, became a showcase for his inventions for over 20 years, providing an example for other sugar factories to follow. Henry Velez then started a successful company to design, manufacture, and install sugar beet processing plants across the United States and Europe before World War II started. One of the 7 habits of highly successful people that were written about by author and professor Stephen Covey is to begin with the end in mind. Begin everything with the end in mind. Throughout my engineering and construction career, I have used this practice by taking two-dimensional drawings and visualizing the final project in 3 dimensions in my mind. To apply this principle in this mission, our vision for the end of this is to see African welders building the world. To help connect African welders with good paying jobs both within and outside of Africa, GFP International has formed a sister company called African Skills and Development Group, with information found at the website address shown here. If you want to become associated with this mission and vision, please pause the video and take a moment to crystallize this image in your mind. This is the end goal of our mission. With many minds focused on this vision, we can make this happen by working together. With that vision in mind, GFP International has created a program to achieve that end, African Welders Building the World. For guidance, we look at how industry leaders in South Africa joined hands 70 years ago to create welding schools to teach welding to international standards. The rest of Africa is sadly 70 years behind. After an analysis of the current conditions, we have designed a $100 million program to modernize, expand, or build up to 30 welding schools to address the seriousness of the problem, and create a scholarship program to help fund the first several years of students going through the school. The organization of the African Welding School and Training Program is depicted here as shown in our third newsletter. We are simultaneously seeking major donors to support the program while also receiving grant applications from welding schools, technical colleges, and polytechnic institutions which want to offer certifiable structural and industrial welding training to their students by creating welding centers of excellence, as we've described here in this lecture. Grant applications will be submitted to a Blue Ribbon Committee of volunteer African leaders from academia, industry, and government to participate in guiding the $100 million African Welding School and Training Fund. These initial members are shown on this page, and we will continue to recruit leaders from across the continent in grant applications so we can reach as many young people and their schools as possible. As already noted, existing welding schools will need to be modernized, expanded with more space, fitted with the latest fabrication training equipment, and fitted with modern welding curriculum. GFP's sister company, African Skills and Development, has selected the most 100 qualified engineers and project managers from a field of hundreds of applicants. These men and women will help schools undertake these projects and work in conjunction with an international accounting firm to provide cost, schedule, and design assurance. This slide shows just a few of these professionals who are posted on the African Skills and Development website. We are proud to have these men and women join our mission and be prepared to travel to project sites across Africa. In addition to a Blue Ribbon Committee and project managers and engineers, we have recruited a team of world-renowned welding training and industrial experts from various sectors across the United States and around the world. These world-renowned welding and fabrication experts, metallurgists, and leaders have also joined the technical team at African Skills and Development Group. This group will support the transfer of all available and relevant open technologies to the African welding schools selected for the program. GFP International has also established supportive relationships with the leading welding technology institutes, including the American Welding Society, the International Institute of Welding, and the Canadian Welding Bureau, to broaden its access to open technologies to transfer to African welding schools. GFP International and African Skills and Development will execute the African Welding School and Training Program with the utmost of professionalism, with the support and involvement of members of the Blue Ribbon Committee of African leaders and the technical experts we have recruited. I am personally committed to this mission and will serve as the program director, applying all the best industry practices of project management, design, development, leadership, and people management as described in my book, On Time and Under Budget, The Ultimate Power of Team Leadership. Now let me speak to the young people and vocational students who are listening. From modern mining, shipbuilding, manufacturing, farming, energy development, and electrification, industrial welding is a key to a modern economy. If you are a student and still think of welding as a low-level skill, this next film clip of a SpaceX takeoff and landing should change your mind.
3, 2, 1. We have liftoff. Vehicles pitching downrange.
Raptor engines. This is one of the most gorgeous things I've ever seen in my entire life. Coming up on hot stage separation confirmed.
Booster coming in. See how fast this vehicle is moving on the left-hand screen. Landing burn.
13 engines.
Booster landing burn shutdown.
top of these stairs.
At the launch tower.
What an incredible view! Wow.
I don't know about you, but we're losing our stuff up here.
Elon Musk's SpaceX hires hundreds and hundreds of welders to perform its work. Modern welding is much more than burglar bars, security gates, and furniture making. It is a high-tech job that is suited for both men and women who want to learn and apply a high-tech skill. When you begin to master the welding trade skill, you meet others from around the globe through the World Skills Competitions. We have connections with the organizers of these artful competitions who can bring these events to the schools we work with in Africa. If you want to have an exciting career with many paths to success and a great life, I encourage you to pursue a career in welding. You will not regret it. At the beginning of this lecture, I told you that I've always been a dreamer. Let me close with the rest of that story. Industrial welding skills are a fundamental building block for a modern economy. It is one of the skills that cannot be learned as an apprentice. It requires months of dedicated practice while wearing a hood, peering through smoke glass, and working under the helpful eye of a trained instructor. The industries that are supported by industrial welding have a high job creation multiplier impact. It costs money to train a welder, and I believe it's worth it. In 2023, just the East Africa region trade deficit stood at $30 billion US. For all of Africa, it is much more. It is affecting the cost of important goods, food, and other necessities. Implementing a shift to more production of manufactured goods and developing domestic resources for local use and processing will be a critical strategy out of this situation, and welding is one of those skills needed to do this. After decades of working in industry across many sectors and gaining a deep understanding of welding training in Africa, I believe that upgrading the welding training to world-class industrial standards will have more positive, leveraged impact than any possible human capital investment that can be made at this time in history. Both directly and indirectly, the economic development it will support could literally raise hundreds of millions of people from poverty and hunger. In practical terms, it will eliminate severe poverty on the continent. More young parents will have a way to feed their kids so they don't go to bed hungry at night, and fewer moms will die from inhaling smoke from cooking fires. These are the dreams that I now embrace in my 7th decade on this planet. To make this point, let me cite the law of Archimedes. Born in 287 BC, he was the most famous mathematician and inventor in ancient Greece who developed the law of the lever, as depicted in this image, which first appeared in Mechanics magazine in London in 1824. Later, in 340 AD, Pompus of Alexandria made a famous quote based on Archimedes' law of the lever. He said, quote, "Give me a place to stand on, and I will move the earth." All of the GFP board members, Blue Ribbon Committee members, technical experts, engineers, and project managers associated with GFP and African Skills and Development stand with the young men and women of Africa who will be the ones to move the earth for the coming decades. We did not choose this mission. By twist of fate, this critical mission chose us, and we gladly accept it with a sense of wonder and shared commitment. Let me now address the resource companies doing business in Africa once again. According to Wood Mackenzie, Africa has the third largest remaining gas resource base by region, and they have reported a whopping $800 billion US in planned energy projects over the coming decade or so. However, as I mentioned earlier in this presentation, you companies are sleepwalking into a nightmarish hell if you do not invest early and now in welder training. Furthermore, I know that many of your projects are held up in negotiations with host country governments over issues such as local content, resource extraction fees, severance taxes, and other issues. Based on my experience and conversations with many African leaders in government, education, and civil society, you would do your shareholders well by investing in real local capacity building now that would not only support your corporate objectives, but provide immense support for the local economies across Africa and build real goodwill with the host countries. Investment in industrial welding training meets both of those goals like no other capacity building investment you could possibly make. To you executives in the mining space, in 2019, the continent produced almost 1 billion tons of minerals worth 406 billion US dollars. How much of that revenue have you spent on capacity building within the countries you operate? Beneath the surface of Africa lies a wealth of mineral resources of enormous value. Africa holds vast reserves of critical minerals like cobalt, manganese, platinum, chromium, and graphite, which are essential for clean energy technologies, not to mention all the other minerals. If you want to succeed in this African market, I have the same message for you as I do the energy companies. You would do your shareholders well by investing in real local capacity building that would not only support your corporate objectives, but provide immense support of the local economies across Africa. Investment in industrial welding training meets both of those goals like no other capacity building investment you could possibly make. Both your top executives and the top African ambassadors assigned to your countries of origin are on GFP's international mailing list and will be watching this presentation and receiving our continued newsletters. These are the African power companies and international shipbuilding companies whose executives are on our newsletter mailing list also. We are also keeping executives of the top 60 banks across Africa informed. I have one final message before I close. According to United Nations statistics, about 3.2 million children die each year from malnutrition in sub-Saharan Africa. That's 9,000 children every single day, 365 days a year. Many millions more fail to develop due to lack of food. Through a combination of my life experiences, education, and career experiences, I have come to see what I see, with the hopes that you will also know now what I know. I could be spending all my golden years golfing with friends, fishing, or walking on the beach, and I do those things sometimes. But it would be a mortal sin for me if I did not commit most of my time working to address this quiet catastrophe that seldom makes the headlines. Please help me and my colleagues and associates at GFP International with your financial support. Remember, give a man or woman a fish and you feed him for a day. Teach a man or woman to fish and you feed them and their children for a lifetime. We are all dedicated to making Africa a better place for its youth and industry, with the parallel goal of ending poverty in 10 years. Thank you for your time today. If you are interested in joining us in this vital mission, please contact me at the email shown below.